Good morning, everyone. Myself, Priya RK, and I'm a top educator in the category of EAMCET. I have been teaching on an academy platform from past 4 months. I also teach in the offline mode for CET, JEE, and also for NEET category. Yeah, just a minute. Okay. Yes. So this is about the plus subscription. So there are three different plans for plus subscription. There is the first plan, that is for 12-month plan, and this 12-month plan cost you around 12,375 rupees. And there is also a 6-month plan which cost you around 10,125 rupees. And we have a trial price for the new subscribers, and that is for 1 month, and this is 2,250 rupees. Good morning, Shafakat. Thank you for joining. Yeah, so here why we need to go for plus subscription is you will get premium content at very affordable price. There will be structured live courses. Doubt clearing sessions will be conducted live, and quiz will be organized at regular intervals for your self assessment. Then there will be a separate batch for the preparation of any different exams that will be taking up. Then test papers, mock test, and also daily practice papers will be provided. And under a single subscription, you will be having unlimited access to the content on Unacademy platform. Good morning, Prathamesh. Thank you so much for joining. Yeah. So in the last class, we have seen more about the molar conductivity, how to calculate resistivity, conductance, and so far we have learned about this. So in today's class, we'll see the further part of this particular chapter, and we'll solve also certain questions. So I request you all to please sit with a calculator. So whenever there is any question, you can just solve it and analyze whether it is right one or no. Okay. Yeah. Fine. So in the last class, we have studied about molar conductivity, how they are dependent on different factors, right? So let us see in today's class what are the different concepts and how it can be related to molar conductivity and so on, right? Okay. So coming to the further part of electrochemistry. So there is also one more term called as limiting molar conductivity. So what is this limiting molar conductivity? Let us just look at this concept. Okay. So molar conductivity we have seen. There is also something known as a limiting molar conductivity. Now what is this limiting molar conductivity? So when concentration of any of the species approaches zero, when concentration of the species approaches zero, the molar conductivity is called as limiting molar conductivity. Hello Rohan Reddy, thank you for joining. Very good morning. So what is limiting molar conductivity? When concentration approaches zero, then molar conductivity is called as molar conductivity is called as limiting molar conductivity. Limiting molar conductivity. Now, molar conductivity, how do we represent? Lambda m, right? Lambda m. Likewise, a limiting molar conductivity is represented by lambda naught m. Lambda naught m. So, lambda naught m is nothing but your limiting molar conductivity. Now, how to calculate this limiting molar conductivity? So, limiting molar conductivity is given by very important law, very important law known as Collage law. Known as Collage law. So, okay, to calculate limiting molar conductivity of any particular solution, what law we use is Collage law of independent migration of ions. So, in short, you can call it as Collage law, or else you can also known it is also known as Collage law of independent migration of ions. Now, what this law states? This law states that limiting molar conductivity of any particular electrolyte can be represented as sum of individual molar conductivity of the cation and the anion in the electrolyte. Now, what is the meaning? So let us take an electrolyte. In short, let me just tell you how it is useful. For example, NaCl. It is a very strong electrolyte because it has complete dissociation. So how does it dissociate? Na plus and Cl minus. This is your cation and this Cl minus is your anion, right? Very good morning, Bhageshri. This is your cation and this particular one is your anion. Now, how to calculate limiting molar conductivity? What they are saying, limiting molar conductivity of which salt or which electrolyte? NaCl is equal to sum of molar conductivities of the cation and the molar conductivity of the anion. That is the meaning. So lambda naught of Na plus molar conductivity of the sodium and plus molar conductivity of the anion, that is Cl minus. So this is the meaning. Now here how many number of ions are formed, that also has to be considered. So lambda m of NaCl, for example, is equal to mu plus, means number of cations. Here number of cations is 1, number of anions is also 1. Okay, so this mu value will be 1 into lambda naught Na plus plus mu minus lambda naught Cl minus. Okay, so this is how the Collage law is stated. That is, limiting molar conductivity of any particular electrolyte is equal to sum of, means addition of the molar conductivity of the cation and that of the anion, right? Okay. So for example, one more, let me take calcium chloride. If you want to write its equation for limiting molar conductivity, first thing you should know, how does it dissociate. Calcium chloride, CaCl2, if it dissociates, it is going to form Ca2 plus 2 moles of Cl minus. 2 moles of Cl minus. Now if I am writing limiting molar conductivity of calcium chloride, what does it form? It forms 1 mole of calcium 2 plus ion, right? So lambda naught of Ca2 plus ion. So mu value is 1, so I am not writing that. Plus here 2 moles of Cl minus are produced. So 2 into lambda naught of Cl minus. 2 into lambda naught of Cl minus. So that is the meaning of mu. Here mu plus is 1, here mu minus is 2. Right? Okay. So based on this, we also have something called as the degree of dissociation. Okay, the degree of dissociation means how much any particular electrolyte is dissociating. For example, if you take a strong electrolyte, then its complete dissociation is there. Its dissociation is 100%, right? But if you take any weak electrolyte, then its dissociation is not complete. So how much any substance is getting dissociated, that is known by a concept called as a degree of dissociation. Very good morning, Sanjana. Good morning, Aparna. Yeah, so that is called as the degree of dissociation. For example, if a strong electrolyte is there, it is 100% dissociating. And if a weak electrolyte is there, it is not dissociating completely. Or we can say it is not dissociating 100%. So we have a term that is degree of dissociation. So degree of dissociation is calculated by the formula that is equals to molar conductivity divided by limiting molar conductivity. Molar conductivity divided by limiting molar conductivity. And also there is a constant. Okay, there is also a constant. This degree of dissociation, it is represented by alpha. Okay, it is represented by alpha. So dissociation constant K, this is dissociation constant Ka is equals to concentration alpha square upon 1 minus alpha. The formula is C alpha square upon 1 minus alpha. Now what is the value of alpha? Alpha is lambda m upon lambda naught m. So C into lambda m upon lambda naught m square divided by 1 minus lambda. Lambda is nothing but lambda m upon lambda naught m. Alpha is nothing but lambda m upon lambda naught m. So here, after cancelling out the terms, what you get is C into lambda m square upon this lambda naught m will come to the numerator, lambda m, this lambda naught m and 1 this lambda naught m gets cancelled, right? So that's how it is only lambda naught m here, not square. Then this lambda naught m can be multiplied here, lambda naught m minus lambda m. And denominator nothing will be there because this is getting cancelled out. 1 lambda naught m here and 1 lambda naught m here, it is getting cancelled. So here it was square, right? So only 1 lambda naught m is remaining. So this is very important. This is dissociation constant. Formula for dissociation constant. So these are very important formula. Based on this, we are going to solve certain problems. This one, that is calculation of limiting molar conductivity, and also based on degree of dissociation and dissociation constant. Okay, all of you can just have a look at these formulas. Yeah. First question, calculate the lambda m. Okay, it's a typo or typing error. Calculate lambda naught m for calcium chloride and magnesium sulfate from the data given. Now the data given is lambda naught value for calcium 2 plus is equals to 119 Siemens centimeter square per mole. Next value that is given is lambda naught of Cl minus is equals to 76.3 Siemens centimeter square per mole. Then for magnesium also it is given magnesium 2 plus, lambda naught of magnesium 2 plus is equal to 106.0 Siemens centimeter per mole. Then lambda naught of SO4 2 minus is also given, that is 160.0 Siemens centimeter square per mole. Okay, very good morning Prajwal, good morning Sachita, thank you for joining. So these are the given values. So these values will be given in the question. What they are asking us to calculate is limiting molar conductivities of calcium chloride and magnesium sulfate. So limiting molar conductivity of calcium chloride. So how calcium chloride dissociates? It dissociates as calcium 2 plus 2 moles of Cl minus. So here the stoichiometric coefficients are also very important. Likewise, magnesium sulfate, it will dissociate as Mg2 plus and SO4 2 minus. Mg2 plus and SO4 2 minus. So coming to the solution, lambda naught M of calcium chloride is equals to, here it is 1, so I'm not writing 1 here, lambda naught of calcium 2 plus here mu value is 2 moles are there, 2 into lambda naught value for Cl minus. Now coming to the substitution, lambda naught of calcium 2 plus is a 119 plus 2 into, what is lambda naught value for Cl minus? 76.3. 76.3. So this is 119 plus 76.3 into 2. Well, good morning Balesh. Thank you for joining. 76.3 into 2. And that is 152.6 Siemens centimeter square per mole. So your final answer would be 271.6. 271.6 Siemens centimeter square per mole. So this is how you need to calculate. Likewise, lambda naught M for magnesium sulfate is equal to, so here both mu values are 1. There are number of ions that are produced is 1 here, correct, of respective cation and anion. So lambda naught value for Mg2 plus lambda naught value for SO4 2 minus is equals to 106.0 plus 160.0 Siemens centimeter square per mole. So this value would be 266 Siemens centimeter square per mole. So very simple question. So that's how you need to calculate the lambda naught M values. These values will be given, lambda naught for different ions. It definitely will be given in the question. Next question. Calculate lambda naught, okay, for HAC. So lambda naught M for NaCl, HCl, NaAC are 126.4, 245.9, 91.0 respectively. For NaCl it is 126.4, for HCl it is 425.9, for NaAC it is 91.0 Siemens centimeter square per mole. Calculate lambda naught for HAC. Okay, for HAC. AC is acetate. CH3 COO minus is nothing but here in short called as acetate. Okay, CH3 COO minus. Okay, now how to calculate this? Here it is not about the ions. Here they have given different electrolytes and you have to calculate. Now I can write lambda naught value for HAC is equal to lambda naught for H plus and lambda naught for AC minus, correct? AC minus. Now how can we obtain this? How can we get this? So lambda naught of HAC, we don't have these values directly, right? We have been given the values of NaCl, HCl and NaAC. So if I take lambda naught of HCl, lambda naught M, should write M all the places, of HCl plus lambda naught M for NaCl minus NaAC, not NaCl, NaAC minus lambda naught M for NaCl. Now what is happening here? You can just see HCl is there, NaAC is there. What we are subtracting? We are subtracting Na and we are subtracting Cl. So from here if Na is going and from here if Cl is going, what is remaining? AC and H is remaining, correct? HAC, and that's what we want to calculate, right? So that's how you need to make any equation in order to calculate it. For example, just to see here, if I write this in elaborated form, lambda naught of H plus lambda naught of Cl minus plus lambda naught M for Na plus lambda naught M for Ac minus lambda naught M for Na minus lambda naught M for Cl minus. Correct? In elaborated form I have written. Now here lambda naught of minus lambda naught of Na and plus lambda naught of Na gets cancelled. Minus lambda naught of Cl minus plus lambda naught of Cl minus gets cancelled. What is remaining? Lambda naught of H plus and lambda naught of Ac minus is remaining. Correct? And that's what we want. We want to calculate that one. So plus lambda naught of MAC minus, right? And how can this be calculated? By substituting these values, because we don't have direct values for these one. So lambda naught of HCl is how much? 425. 425.9 plus lambda naught of NaC is 91.0 minus lambda naught of NaCl, that is 126.4, and the answer is, just add these two and then subtract this one. Answer would be 390.5 Siemens centimeter square per mole. So you need to make an equation in such a way that it is going to provide you the final answer. Very good morning, Swati. Thank you for joining. Yeah, if you have any doubts, you can comment in the comment section. Okay. Yeah. Good morning, Preeti. Yes. So coming to the next question, the conductivity of 0.001028 mole per liter means what is given? We'll see this question. What is given? Concentration is given. How much it is? 0.001028. Correct? This is the concentration given, mole per liter of acetic acid is 4.95 into 10 raised to minus 5 Siemens per centimeter. Means conductivity. Conductivity is represented by K. What is the value? 4.95 into 10 raised to minus 5 Siemens per centimeter. Calculate its dissociation constant. If lambda m, dissociation constant, means which value we have to calculate? Ka value. What they are given? They have given lambda naught m. Lambda naught m for acetic acid is 390.5 Siemens centimeter square per mole. Siemens centimeter square per mole. Okay, so first thing, we know the formula of a K is equal to C alpha square upon 1 minus alpha. Just now we have seen, let me just go back to that slide. Yeah, Ka, dissociation constant, is equals to C alpha square upon 1 minus alpha, right? And what is formula of alpha? Lambda m upon lambda naught m. Okay. So this alpha value we don't have. So alpha value, if you want to calculate, it is lambda m upon lambda naught m. Lambda m upon lambda naught m. Now how to calculate this lambda m? That also we have seen in the last class. Lambda m is equals to K upon C. K value is given in the question, 4.95 into 10 raised to minus 5 Siemens per centimeter. Concentration is also given, 0.001028 mole per liter. If you just convert this, centimeter is there, this is liter is there, right? So in order to convert this, you have to multiply this by 100. There are two formulas, right? We have seen in the last class. One is in the terms of centimeters, one is in the terms of meters. So this is 100,000 into 1000, right? Just to convert it into liters. So this would be 48.15. If you divide this, 48.15 Siemens centimeter square per mole. Siemens centimeter square per mole. So now we have got lambda m value, and lambda naught m value is already given in the question. So alpha value we can calculate now. Alpha value is lambda m upon lambda naught m. Lambda m that we got is 48.15 Siemens centimeter square per mole. And lambda naught m value is 390.5 Siemens centimeter square per mole. So if you just divide this, units will get cancelled, and what answer you get is 0.1233. 0.1233. This is the dissociation constant, so it doesn't have any unit. Then degree of dissociation. So this is degree of dissociation. Dissociation constant is C into alpha square 1 minus alpha. C value is given in the question 0.001028 mole per liter into alpha square. Alpha value is 0.1233 square divided by 1 minus alpha. 1 minus 0.1233. Right? So if you just solve this, square this, subtract this and this, multiply and divide it. So what you get is 1.78 into 10 raised to minus 5 mole per liter. If you're not able to convert it into exponential form also, it is okay, but you should know how to convert anything into a particular exponential form. Right? So these are the different questions that may be asked from this particular topic, right? Okay, next going to the next particular topic, that is electrolytic cell and electrolysis. Electrolytic cell and electrolysis. Okay, so electrolysis and all we have already seen, correct? So electrochemical cell we have seen, where the external potential is less than 1.1 volt, and therefore current flow, electrons flow from zinc to copper and current flows from copper to zinc. But when the potential is greater than 1.1 volt, then the cell is reversed. That time electrons will flow from copper to zinc and current flows from zinc to copper. Right, zinc to copper. So that cell we call it as electrolytic cell. So this electrolytic cells help us in determining the amount of current that is flowing, right? So there was a scientist called as Michael Faraday. Michael Faraday. He gave two laws, okay, and these are known as Faraday's law of electrolysis. What are these laws useful for? These laws help us to determine how much electricity is passed through, or how much electricity is passing through a particular solution during electrolysis. So Faraday's laws of electrolysis. Faraday's law of electrolysis. So there are two different laws. There are two different laws. There is first law, and also there is one more law, that is second law of electrolysis. So there are two laws of electrolysis, first law and second law. What this law, first law states that the first law says is amount of chemical reaction, which occurs at any electrode, during electrolysis by current is proportional to quantity of electricity that is passed. Is proportional to quantity of electricity passed through the electrolyte. Through the electrolyte. Now what it is meaning? How much electricity you are passing, that much chemical reaction will occur at any particular electrode. That is the meaning of this particular law. Right? So what is the first law? The first law states that at any particular electrode, the amount of quantity or quantity of electricity that you pass, depending on that particular reaction will occur. Right? What is the second law? The second law is nothing but the amounts of different substances. Now this is the reaction that is happening. After the reaction happens, there should be something that is produced. That is the product that has to be produced. So that is relating to the second law. What the second law states, the amount of different substances liberated means formed. The amount of different substances liberated or formed by the same quantity of electricity, by the same quantity of electricity passed through the electrolyte is proportional to the chemical equivalent mass. The chemical equivalent mass or weight of the substance. So what this law in short I can tell you is, at any particular electrode, if any new substance is produced, it is produced by passing some quantity of electricity through the electrolytic solution, and how much substance is produced, that is equal to its chemical equivalent mass, that is equal to its equivalent mass. So these are the two laws of Faraday. So based on this, there are different formulas also. We'll see it in the next class. So thank you everyone for joining. So my next YouTube session is on 24th, that is the day after tomorrow. So all of you can attend that YouTube session. And today on Unacademy platform, I'm taking a class at 10:45 to 11:45 a.m. and also from 12:45 to 1:45 p.m. So the interested students can follow me on Unacademy. The link to my profile you can find in the description box of this particular video. You can just go to the description of this particular video and look for the link to my profile. So today I'll be taking classes on Unacademy platform at 10:45 to 11:45 and also from 12:45 to 1:45 p.m. So all of you can attend those classes as well if you are interested to. So thank you so much for joining. See you all on 24th on live on YouTube session, and today's Unacademy session will be at 10:45 and 12:45 respectively. So thank you so much. Have a good day.